Hi, I'm Aaron Reedy. I'm the co-founder and CEO of Data Classroom. I was formerly a high school science teacher in the Chicago Public Schools, but I made Data Classroom to be a set of tools for graphing and statistics that I always wished I had in the classroom, and I built it to be a set of tools that helps students learn to work with data as they get their first experiences in working with data. We never set out to make a tool that was aimed at science fair, but it turns out science fair is a really important audience for us. And I can honestly say, if it weren't for science fair, we probably wouldn't made it through the early days of our company. So we feel extremely grateful to the science fair community. And we're also proud sponsors of ISEF and the Science Fair Directors Institute. So we love engaging with the science fair community. And I'm excited to show you Data Classroom through the lens of what it can do for a science fair student. So with that, let me go ahead and share my screen. And I want to first show you our website. This is our public face and where a lot of people find out about our tools. Once you go to dataclassroom.com and once you log in, you will arrive at our web application, which is the Data Classroom tools. And you will come to a dashboard that looks something like this when you arrive at the Data Classroom dashboard. And again, you've logged in to get to this point. And from here, I'm going to open up a data set from our library. Now, I'm in a little bit, I'm going to show you how to bring in a science fair data set, how a student would do that. But to start out with, I'm just going to go ahead and pull a data set out of our library, demonstrate some of the basic graphing and stats capabilities, and then we'll circle back into data upload. One of my all-time favorite data sets to demonstrate is called Cicada Sex Education. Let me just go ahead and search it up here. This is looking at cicada population data across North America. It's a good data set. It's got a few hundred observations, so you can see what graphs look like when you have a good number of data points. Um, and it also has a mix of numbers and categories, so I can make pretty much all of the graph types that I would want to in here. This is um, the data table view within Data Classroom. This is probably the most similar view to a traditional spreadsheet. You can see up here at the top, there's a flow chart that takes students through preparation, visualization, and statistics. This is going to become really important when students are working with their data. And then the rest of the screen you can see is the data itself. And you can see each variable has its own column. Each observation is a row. This is called tidy data format, and this is hugely important to science fair students who are learning to work with their own data. I'll come back and talk about that a little bit more in the future. Let's take a look at graphing with Data Classroom. I'm going to go ahead and take a variable of interest to start out with here. Maybe I'm just going to look at this categorical variable called sex. I click the button and we get a plot. And this is what we call a categorical bubble, but this is just one way to look at categorical data. I could switch and look at a rectangle-based graph, and we can see this is a stacked bar chart. I can also very easily unstack this and just look at what this would look like as a sort of a traditional bar chart, just showing those frequencies of both male and female. I can look at these as a pie chart. And the point I want to make here is it's very easy to toggle through these different representations of data. This is really important for learners. I would definitely recommend to science fair students where you're going to be presenting your data in a competition setting. You want to be confident that you have chosen the representation of your data, which is most clearly presents the story you're trying to communicate to the judges. So that becomes very important to move between graph types. Let me add a different variable here. So we have sex on the plot. I'm going to show head width. And now we can see it moved sex down to X, and I can see my two categories, female and male, and I can see all of the representations of head width there. If I go ahead and choose a different graph type again, now we can see head width with these histograms that are kind of laid on top of one another. And students can really play with those alternate visualizations. I'm going to go back to the dot format. This is one of my favorite ways to represent data. And you can see I get options that appear to the right of the graph as they might become necessary. Here you can see me playing with the jitter. This is just the horizontal spread of the data, or I could do things like add descriptive statistics. Here I've added box plots showing the median and the interquartile, and the whiskers are showing the range. I'm going to actually go in the appearance, and again, if we're making data to present in a competition setting, the appearance is really important. So I'm going to open up the appearance menu. I'm going to make a different kind of graph here. I'm going to make these data points a little bit smaller. I'm going to maybe drop the grid lines that are in the background there to just go with a cleaner look. I'm going to let me go to mean bars boxes here. One second. And in this, I'm going to actually position the boxes right on top of the data, and I'm going to make those indicators um, a little bit bigger. This is one of my favorite ways to represent data because you get the nice visuals of the summary where you can see the mean and the interquartile. But you can actually see the raw data as well. I'll maybe even turn those down just a little bit and maybe take the edges off of them. So you have a big sample size in this case. You can show it off to the judges by keeping it visible there. But you've also really, drawn the eye to the nice comparison between medians there. Um, from here, if you want to go on to statistical analysis, we believe you should make the graph first. And this, to be honest, is one of the features that is most beloved by science fair mentors, because they can have a student make a graph like this that they want to present. And then when the student comes to them and says, what kind of analysis should I do? They can get Data Classroom to help them out with that, and it can actually reduce the number of questions that are being brought to the mentor, and it can empower students to do some of this on their own. So if I launch this button right here, and you see me hovering on it, this is the graph-driven hypothesis test, and it's going to take a look at that graph, and it's going to recognize that, hey, this looks like pretty classic t-test data, or if I want to use a non-parametric equivalent, I could use Mann-Whitney U in this situation. But when I click on this, it's going to open it up and it's going to say, hey, we recommend t-test. And I can also turn this button on. A lot of science fair students will want to do this. This is going to show the advanced options. So I get a wider range of statistical test choices, but you can see that it is still recommending t-test, and it's assuming a normal distribution. You can see we have two categories on X, we have a number on Y, and I can go ahead and click calculate, and it's going to give me, as a student, it's going to give me an explainer that is saying, why am I using a t-test in this situation? When do I use a t-test? How does it work? This when should you use it? This is the kind of information a science fair student should be ready to talk about with a judge, right? A judge might ask a question like, hey, I see you did a t-test here. Why did you make that choice of analysis? And this provides students with the information that, well, a t-test is used when I'm testing for a difference in the average value of a numeric variable between two different groups. So a student might internalize that and be able to answer, well, I had two groups and I wanted to know if they were different in terms of head width, or I wanted to see if the average was different across these two groups. That's the kind of understanding of their analyses that is really important for a student to have and to be able to defend. So this is all aimed at building that up for a student. And here you can see it's going to give them the kind of standard statistical output that they'd report in their paper or on their poster, their degrees of freedom, their test statistic, their probability value, and they can also get some help on this interpretation of P. If I click explain here, it's going to frame the question in the blue box. So they can see that this graph is posing the question of, is there a significant difference in head width between the two groups, which were female and male? And then they can see that their p-value of less than 0.01 means extremely strong confidence that the groups are different. And the rest of the text in this box is cautioning against overinterpreting. It's trying to help them understand that statistics and science doesn't produce yes or no answers, but instead it really just gives you probabilities, or it gives you a measure of confidence in your data. So that's what this is aimed at doing. And to give you, the full picture of what this does, right? If I make a different graph, so I'm going to, instead of sex on X, I'm going to put species group on X. And we can see these three species groups, Decim, Cassini, and Decula. This is no longer t-test data. This is now ANOVA data. And if I launch the graph-driven test, it also recognizes that, hey, this is ANOVA data because we have more than two categories on X and we're still comparing a number. And when we click calculate, we get an explainer that explains, why is the ANOVA a fit? How does it work? And again, why are we using it, right? Why are we even doing this? So then it will go ahead and it will calculate. It will give us our p-value for the overall model. But because this is an ANOVA and not a t-test, we might want to run post hoc tests. This is the test we use to figure out which of those three groups are different from one another. And I can launch my post hoc test. I can see that, in fact, all of the pairwise ways that you can compare these three groups are different from one another. And that's these three p-values down here illustrating, each of these comparisons: Cassini versus Decim, Decula versus Decim, Decula versus Cassini. And I can also annotate this if I want. This blue button up here will give me the opportunity to annotate that. I'll go ahead and annotate all three of those comparisons. So these three checkbox, but maybe I'll change and I'll make these annotations black on the graph. Then when I click confirm, you can see those comparisons are now pointed out on my graph. I know this is a really popular kind of graph type in science fair, and we've recently added the ability to do this largely from talking with the science fair audience out there, and learning about what you all want on poster presentations. And also, I should add, we go to science fairs ourselves, so we see what posters are, what students are using in posters for their figures, and we want to give the ability to do those kinds of visual representations that are important for science fair. So that, that's the basics of how the statistics works. You can also get help with graphing, but maybe before I show that help with graphing, I'll go through the process of data upload that a student would do. So I'm gonna leave this. I should point out I could save my work here and come back to this. So if I said this is my file here, Cicada Sex Education for Science Fair, I can save it, and I can come back to that at any time that I wish. So students can save all of their work on their Data Classroom account. But I'm going to actually close out of this. I'm going to go back to the dashboard, and I'm going to go to this button that says import data. So I'm going to bring in my science fair project here so you can see how a student would do it. Here at this point, I have the option to fetch a data from Google Drive, fetch a data sheet from Google Drive, upload a spreadsheet from my computer. That's what I would do if I had an Excel or a CSV file. I can even copy paste the data into the cell, or I can create a blank data table. Let me go ahead and grab some data. So this is a Google Sheet, and you can see this is survey data. And survey data is extremely common in science fair, as I'm sure a lot of you know. And you can see students, they recorded data. Each row in this observation or in this data sheet was a different survey. So each row is a different survey. And you can see they asked questions about personality type. Are you an introvert or an extrovert? Do you have a pet preference? Are you a dog person, a cat person, or neither? What is your typical Friday night plans? Do you prefer to work in groups or independently? What's your favorite social media platform? But this is my data, and maybe I collected this with Google Forms. Um, but here it is in the Google Sheet. I'm just going to copy the web address of the Google Sheet, and I'm going to go back to Data Classroom. I'm going to click this fetch option, and I'm going to paste in the web address of my Google Sheet. Every Google Sheet is a website. And so now Data Classroom knows where to find this information. And if you give your Google account permission to talk to Data Classroom, I can go ahead and I can just fetch it in. Um, and so it's bringing in the data. And now one advantage over using this integration with Google Drive that is a big advantage over just a regular file upload is if I change the original Google Sheet, I can refresh the data and bring in the most recent version of the data. Once the data comes in, students are going to be started on that checklist with the first steps being preparation. And you can see it's pointing out a little warning that some of my column headers are quite long and will be difficult to fit on a graph as a label. So I'm going to say I'll fix this, and I'm going to actually show you how to fix this. So this one right here, this column that says which of these two personality types best describes you, this is the one that's too long. And so I'm going to click on this edit, and you can see here's the name, and I'm going to swap it so it goes down into the description field. And then I'm just going to rename the variable and just call it, personality, and click OK. And now you can see I've got that shorter heading. If I hover on the little blue information button, it gives me the description that was in there. So this is a really useful way to clean up survey data for analysis. Looking at the flowchart, you can see preparation is done, data import's done, and we're now on to this step that's called prepare. And here it's asking me to give a description of my data and choose a data type and for each variable. And if a student doesn't know what these things mean, they can click on learn more. I can see it's explaining, what type is my variable, and it's explaining, what the different types are. But I'm going to go ahead and say I'll fix this and I'll do these things. So starting over here, social media most, this variable is categories. And you can see I get a different color for every category. I have 5 of them there. Preferred work, independent or group, this is categories. Friday night plan, this is categories. Pet preference, this is categories. Personality, this is categories. Sex, this is categories. Grade, this could be numeric or categories, but I will say you probably want to consider this as categories. And this choice will affect the different possibilities you have. It doesn't have to be a permanent choice either. You can always, try it as categories, then later try it as numbers if you want. And then student ID, this is just an ID number. We're not really going to analyze this, so I'm going to say that it is an identifier. And then the last thing I'm going to do is I'm going to go up here and, give a description. And I'm just going to say that this is demo data, and that's what we'll call it. And you can see now the flow chart is done, and I can go on to graphing. And now I can just jump over to the graph tab and make graphs just like I did with the cicada data. But I want to also show you where a student could get a little help here. And they can choose to open the graph wizard. And this is going to give them a stop and think moment where they have to think about, what is it that I'm trying to illustrate? Is my question about proportions? Is it about change over time? Is it variability? Is it comparing groups? Is it about relationships? And this is going to help them get to graphs that are acceptable for the kind of data that they want to show. Let's say our question was, we want to know for those variables that were pet preference and personality, which was extroverts and introverts. Maybe we just want to know, are the proportions of cat and dog people, does that differ based on whether you are an introvert or an extrovert? That's a question of proportions. It's all categorical data. If I click this path and we come down here, Now we're going to be asked, are we looking at one variable or are we looking at two? We're actually looking at two here. And, first variable, let's say personality. Second variable is going to be pet preference. And now it's going to show us that we have three viable options to do that. We could use this categorical bubble. We could use bar graph with X and Z variables. So bar graph with two variables, and we'll take a look at that. Or we could do the stacked bars. I'm gonna go with the very traditional bar graph with two variables here in the middle. And I'm going to say, show me the steps, and it shows me that I'm 6 clicks away from having that graph, but I'm going to click do all, and it's just going to go ahead and jump to the graph tab and set that up. And I can look at my graph. Now, this doesn't have to be a finished product, right? From here, I can just say, oh, what would this look like with the bubbles? Okay, that's what it looks like there. I'm going to go back here. I could also start tweaking the appearance and say, you know what? Actually, I want to stack these and I want to normalize the y-axis. I want to stack as proportion. So instead of raw numbers on y, I can see percentages. And I can look at these data this way and say, oh, actually, it looks like the composition of pet preference across the categories of neither, dog, cat, it looks like it might be different. It looks like maybe I have more cat people among the introverts there, maybe slightly fewer dogs and maybe fewer neithers as well. Now, if I wanted to analyze these data statistically, what's the appropriate test here? Well, I know as an experienced mentor, this is a chi-square test of independence. And if I go over here and launch stats again, it's recognizing that and it's saying, hey, this looks like chi-square test of independence. And when I click calculate, it explains what's the situation where we use that. Well, this is when we have two categorical variables, and we want to know if the value of one appears to be dependent on the other, right? And so this is the situation for this test. And I can click calculate, and it'll tell us that, we have a p-value of 0.07. This is kind of a tricky one to interpret. It's right on the line. But when I click explain, it's gonna frame the question in the blue box. And it's going to let us know that we have some confidence that there is a relationship. And if we read the text, we'll see that, this is about a 7% chance of getting data like these as random. It's not below our 0.05 threshold that is so common in science. But it's also important to note that, 0.07 we could kind of treat as some confidence. And as we move over to, 0.04, 0.05, this is just the zone of strong confidence. So it's also helping students understand that, this is not a yes or no answer, right? It's just a probability. And, so at this point, students could elect to, present that data with some nuance. Or they could, get motivated to say, wow, this is pretty close to statistical significance. Maybe if I collected, 20 more surveys, maybe I could present a significant result. So, that's the kind of thing. But no matter what the student chooses to do with the data, we want them to be better able to understand what they have and what conclusions are really supported by the data that they have. So that's a walkthrough of how a science fair student would analyze that data. I'm gonna bring up just one more data set from the resource library because I want to demonstrate a couple of other features that are particularly useful to science fair students. I'm going to open up this data set that's called Life on the Edge. I couldn't demonstrate this with the last data set because it had all categorical variables and I needed some numbers here. But what I want to point out is this advanced menu. And if I go to this hamburger menu over here on the upper left, I can get additional tools that come out of the left-hand menu. And under advanced, there's a few things that can be of particular interest. One of these is the melt function, the count function, the uncount. These are really important tools that can be incredibly helpful for helping a student take a data set that is not in tidy format and tidying it up. So these are really powerful tools for cleaning up a data set for analysis. Um, if you look on our website, we have some more videos that go in depth on those things, but I just wanted to point out that they're there. We also have this hypothesis test button. This is a way to do hypothesis tests without graphing first. There's also a wider range of hypothesis tests in here. Most notably, they can do multiple linear regression. That's what they would do if they have multiple predictor variables and one response or dependent variable. You can't do that from the graph because there's no real easy way to graph that kind of a model, but they can build that in there. So I wanted to point out that that is there. But then the other thing, and I just want to show you this. So again, in the advanced menu is the correlation matrix. This is actually popular with numeric survey data. Maybe sometimes where you've using Likert scale data or something like that. But if I select all my numeric variables in my data set, I can make a correlation matrix like this. I have two different options for kind of correlations that I can show. I can show Spearman's rho. This is the most appropriate correlation to show if you are working with Likert sort of survey response variable, numbers 1 to 5 or 1 to 7, because it's a correlation that doesn't depend on those numbers being numeric values that are all, 1 is equidistant from 2 is equidistant from 3. It can actually just be, survey responses where it's maybe not on a numeric scale. If you have true numeric data, you can use a Pearson correlation coefficient that's appropriate for this, which in this data set, that would actually be a fit. And then you can see the values of those correlations between any two variables in the matrix there. And you can see the diagonal is all 1.0s because the correlation between any variable and itself is 1.0. I can also customize the appearance of this. I can choose a different color scale. I can change the header sizes. I can also choose to show the p-values on the correlations themselves, and I can turn on and off the corrections for multiple comparisons. Our default is to leave them on. I would recommend always using those. Just that gives you a more defensible result if the judges really want to dive into the stats. I can also do things like color the positive and negative values differently. I could fill in the matrix if you prefer a completed square, but again, that's just a mirror image of the 1/2 of the matrix. So that's an important feature for science fair. And again, another feature that came out of conversations with science fair people like yourselves that really let us know that we needed to add this for the science fair community. Um, so I've taken you through, graphing with a data set, looking at different graph types. I've talked you through applying statistics, launching them from the graph-driven test as well as from the advanced menu. We've looked at, how students get their science fair data into Data Classroom. We've looked at how you prepare data for analysis, and then I pointed out some of the advanced features that are helpful to science fair. So with that, I will just say, if you're interested in working with Data Classroom, we would love to talk with you. My personal email is aaron@dataclassroom.com. That's AARON at dataclassroom.com. And we love to talk to science fair people. So if you think this might be a good fit for a school that you work with, or a school district that you work with, or a mentor that you work with, we would love to talk with you about it. So please don't hesitate to reach out. Best of luck with the important work that you do. I think science fair is really important for kids as individuals. I think science fair is really important for science education as a whole. I think it points the way for what classroom science could and should be. And it's important to get students involved in doing real experiments, and that's one of our important motivating factors here at Data Classroom too. So with that, I'll say, thanks for listening, and I hope to talk to you soon. Hi, I'm Aaron Reedy. I'm the co-founder